Section 7.4, Rationalizing Denominators or Numerators with Two Terms. The use of conjugates allows us to rationalize denominators or numerators that contain two terms. So they're asking us to write an equivalent expression here with a rationalized denominator, which means we need to get rid of the radical or radicals in the second example. And to do that, we're going to multiply using the conjugate. And if you recall from earlier in this course, a conjugate is a binomial that has the same first conjugate pair, is a binomial that has the same first and second term, and the only difference is one has a plus and one has a minus. So the conjugate to this denominator is going to be 3 plus the square root of 5. And it turns out that if you multiply conjugates together with radicals in them, they eliminate the radical. So we're going to multiply the denominator by the conjugate of the denominator in hopes of rationalizing the denominator to get rid of the radical, in other words. And to have an equivalent expression, we also need to multiply the numerator by that same quantity. This binomial over this binomial is equivalent to 1, so we're maintaining our equality. And we'll hold off with doing the distributive for right now, similar to when we were factoring and multiplying polynomials together. To ensure that we've reduced it, we would hold off on the multiplication. We have a binomial times a binomial. If we use the FOIL method, multiplying the first terms together, 3 times 3 gives us 9. When we multiply the outside term, 3 times the square root of 5 gives us the following, and a negative times a positive for our inside terms gives us a negative 3 times the square root of 5. When we add those like radicals together, they cancel one another out and leaves us with our last terms multiplied together. A negative times a positive is a negative, and the square root of 5 times the square root of 5 is the square root of 25, or 5. You can think of this as a minus b times a plus b results in a difference of squares. Square the first minus the square of the second term. Our radical's gone. The only thing left is to simplify. In the denominator, 9 minus 5 is 4, and we have the 4 times the quantity 3 plus square root of 5. Now we'll look to see if there's a common factor in the numerator and the denominator, and we do have a common 4 over 4 is equivalent to a 1, so that our final answer is 3 plus the square root of 5. We not only rationalized the denominator, we eliminated the denominator. It's not always the case. In this next problem, they're asking us to rationalize the denominator here. So to do that, we will multiply by the conjugate of the denominator, and the conjugate of the denominator is the same first and second term, but the opposite sign. So instead of a minus, we'll put a plus between those two terms. And to maintain equality, we'll multiply the numerator by that same expression. So here, to simplify, we will multiply the numerators using the FOIL method. So first terms multiplied together, we have a 3 square root of 2 times 5 times the square root of 3. We'll have the 3 times 5 gives us 15, and underneath the radical, a square root of 6. That's the first terms. The outside terms, we will have a 3 times 4 is 12. Square root of 2 times square root of 2 is 2. Inside terms, we have 5 times 5 on the outside of the radical is 25. And we have square root of 3 times square root of 3 is 3. Last terms multiplied together, outside the radical, we have 5 times 4 is 20. And underneath the radical, we have the square root of 3 times square root of 2, which is the square root of 6. Well, that's what's going on in the numerator. The denominator, we have a difference of squares as a result of multiplying the conjugates together, but just to show that that is the case, multiply our first terms together. 5 square root of 3 times 5 square root of 3. Well, the 5 times 5 is 25. Square root of 3 times square root of 3 is 3. Our outside term would give us a 20 square root of 6 when we multiply. Our inside, a negative times a positive, would be a negative. 4 times 5, 20. Square root of 2 times 3 is square root of 6. Those two terms are opposite, so when added together would cancel out. And last terms, a negative times a positive. The number out in front gets multiplied for a negative 4 times 4, or 16. Square root of 2 times square root of 2 is square root of 4, resulting in 2. Simplifying this further, in the numerator, 12 times 4 is 24. 25 times 3 is 75. Combining like terms then, we have a 15 times the square root of 6 plus 20 times the square root of 6. Turns out to be a 35 square root of 6. And combining our integers, 24 and 75, is a 99. In the denominator, 3 times 25 would give us a 75. 16 times 2 is 32. And we're subtracting, so we end up with a 43 in the denominator. Always should be aware of the possibility of simplifying, and before we look to cancel, check and see if there's anything common to factor out in the numerator. 35 and 99 have nothing in common. 35 is 7 times 5, 9 times 11. There's no common factor, so there's nothing to factor out, and so this is in reduced form. It works the same way if we're asked to rationalize the numerator, which means to eliminate the radical from the numerator. And since this is a 2-term, the only way we can eliminate that is to multiply by the conjugate. So with that we have conjugate pairs, which means it's the same first term, opposite sign, and same second term in the numerator as in the denominator, because of this is equivalent to multiplying by a 1. In the numerator, we have a binomial times a binomial. We'll FOIL it. First terms multiplied together. Square root of 3 times square root of 3 is 3. Outside and inside will cancel out, leaving us with our last terms multiplied together. Positive 2 times negative 2. Positive times a negative is a negative, and 2 times 2 is 4. In the denominator, we'll leave it as is, as a binomial times a monomial looking term. Simplifying in the numerator, 3 minus 4 is a negative 1 over 5 times the square root of 3 minus 2. We have rationalized the numerator by multiplying by the conjugate of the numerator and eliminated the radical.